All right, good morning, calculus friends. We got some mathy stuff to do today, and today we're going to introduce a new topic called integration with respect to y. So we've been dealing with area and volume, and everything that we've done up to this point has been with respect to x. And what I mean by that is our triangles, I keep saying triangles in my brain here, it is going to be rectangles line up going across. When we're finding area, we're looking this direction when we're accumulating area. Today we're going to change that. We're going to actually look towards the y. We're going to work our rectangles going up. So let's start with an example, and let's go ahead and put this up on the board here. So we're going to find the area of the region bounded by f of y is equal to y over the square root of 16 minus y squared. F of y is equal to 0, and y is equal to 3. Looks like a G. It's supposed to be a y. Best I can do. Okay, so find the area bounded by these. So one thing to note, normally when we use function notation, we write function notation like this. We write a function f of x, and by f of x we're saying y. This is the opposite of that. This is actually saying, by saying f of y, we're actually saying x. So the function is just written, it's a function of x with respect to y, or we're writing x as a function of y. This is y as a function of x. Okay, let's get a diagram, as always with our area problem. So there's a different color for that. And I know we probably do not know what this looks like. That's totally fine. Here is what this looks like. It looks like this, and comes down and goes in this direction. And we're bounded by the line y equals 1, 2, 3. So that's right here. And we're also bounded by x equals 0. So again, this is like saying x. So that would be this right here. And then y equals 3. And this, and here is the area that we are looking for. Okay, so in order to do this, we're going to go ahead and we're going to integrate. But some unique things happen when we integrate in this one, because we're integrating a function with respect to y. And what that means is normally when we do our rectangles, they're lined up like this, and we have infinite many rectangles. In this case, our rectangles are going to be lined up this way, and we're going to be accumulating area as we move through the y's vertically. Otherwise, it's going to work exactly the same. So we're going to integrate. We're going to do the integral. Okay, so we're going to integrate with respect to y. Our lower limit for y is going to be 0, and our upper limit as we move this way is going to be 3. We're simply going to integrate this function right here, which is going to be y over the square root of 16 minus y squared dy. And let's go ahead and I'll actually do this one for us. So I'm going to rewrite this. This would be the integral from 0 to 3 of y times 16 minus y squared to the negative 1/2 dy. And let's see, I got a chain here. This is going to need a negative 2, which would mean this would have a negative 1/2 out front. So we'd have negative 1/2 getting pulled back in. This is going to be 16 minus y squared to the positive 1/2, which means I need a times 2. And we're doing that from 0 to 3. This is going to cross off, and I'll be left with negative 16 minus y squared to the 1/2 from 0 to 3. All right, let's plug it in. So we'd have negative. I'm going to take that negative out and just put it on the outside. Plug in 3 would be 16 minus 9 is going to be square root of 7. Minus, plug in 0. I'm going to end up with square root of 16, which is 4. So I'm going to end up with, in the end, I'll go this direction in case I'm going off the board. These negatives, it's going to be 4 minus root 7, and that is approximately 1.35 something. And I should have gone a third decimal place, but I didn't, and I don't have my calculator with me. So this is what we get, friends. All right, so what's different about this one? The difference is now we're integrating this direction. Normally, we're integrating this direction. All right, let's do another example here. We have 3 examples that we're going to do. Split the board right here, and let's do this example right here. So we're going to find the area of the region, bound it by y is equal to x plus 2, y is equal to the square root of x, y is equal to 2, and y is equal to 0. All right, step 1 on these problems, I'm going to get a picture. Just going to help me make sense of this situation. So I want to know what's bounded here. So y equals x plus 2 right here looks like this. We got square root of x, y equals square root of x. We know that looks like that. Y equals 2 is going to be a line going this direction. Y equals 0 is right here. Here is the function that I'm going to, not the function, that's the area or the region that's bounded. All right, so let's set up our integral. We're going to do this a couple ways. The first way we're going to do is the way we know how to do this. What I mean by that is we're going to integrate going this direction first. So if I was going to do that integral, this is on top right here. So I'm going to make sure I use that first. And we're actually just talking about the top minus. This would be 0. So I would have area is equal to the integral. And this is going to go from negative 2 to 0. And this function right here is going to be x plus 2 dx plus, now this one's on top and I'll have to subtract the bottom. So I would go the integral from 0 and this is going to go until y equals 2, which means this is going to be 4. So it would go from 0 to 4 of the top function, which is just going to be 2, minus the bottom function, which is going to be root x dx, which is not a big deal to do. And you're going to calculadora that up, or we can do that all, and I'm going to tell you you're going to get, what are you going to get? 14/3. Okay, let's try it a different way though. So let's integrate this one. Instead of moving across this way, let's move upwards. That means we're going to integrate with respect to y. In order to do that, I'm going to have to rewrite my functions, because in order to integrate with respect to y, I have to have my function x written as a function of y. What does that mean? That means basically I need to change the way these look. So I'm going to change the way this looks by solving for x. I'll subtract 2. I'm going to end up with x is equal to y minus 2. For this one, I'm going to square both sides. I'll end up with x is equal to y squared. Okay, and let's integrate. So this one is going to be easy to find our limits because it's going to go from 0 to, and it's a height of 2 there, because y was equal to 2 was one of our equations. So let's write our equation now. So area, we're doing it with respect to y, I would go from 0 to 2. Now, when we do this normally with respect to x, we do the top minus the bottom. We're going to do something similar to that, but we're going to do the right-hand one minus the left-hand one. In other words, I'm going to do this function right here minus this function right here. So this is going to be, this function right here is going to be our y squared minus this function right here, which is going to be my y minus 2. And there you go. Okay, just 2 different techniques. This is with respect to x. This is with respect to y. Again, we're moving in this direction. That's how rectangles look. Either way, you're going to get 14/3. Not going to go through all that mathy math stuff. All right, so I got one more example for us. And go ahead, I'll erase the board. And then we'll do the next problem, friends. All right, peeps, let's do our last example here. And we're going to have one here. This is going to be determine the area of the region bounded by x equals 1/2 y squared minus 3 and y is equal to x minus 1. All right, so first things first, let's get a graph of this. So this is a little different. This is a function x written in terms of y. And let's think about what this would look like. And the way we're going to think about what this would look like is, what if I had y equals 1/2 x squared minus 3? What would that look like? Well, it'd be a parabola. It'd have a y-intercept of -3. It'd look like this. This 1/2 would widen this out a little bit. But again, I'm just getting a sketch. So what does it look like for this? Well, that's just going to be very similar. It's just going to be on its side. So it's going to be, let's make a formal graph for this. This would go from -3 in terms of x, and it's going to go up in this direction and be a parabola on its side. And then we have the line y minus, or x minus 1. That's going to be like this. Maybe it has a slope of 1. Boom. Here we go. Boom. Here we go. Okay, so we're going to integrate this. And if we're going to figure out how to integrate this, we are going to need to know where these intersect. So where do these intersect? I'm going to tell you, I better check and see where those intersect. This is the coordinate 5, comma 4. And this right here is the coordinate -1, comma -2. And you could have figured out how to calculate those. All right, so we're going to do this in two ways. We're going to integrate first with respect to x, and then we're going to set this up and integrate with respect to y. And actually, it's going to be much more of an advantage to integrate with respect to y in this one. First of all, if I'm going to integrate with respect to x, I'm going to have to rewrite this function by solving for y. The way I would do that, I would have 1/2 y squared is going to be equal to x plus 3 times 2. Y squared is equal to 2x plus 6 square root. Y would be plus or minus the square root of 2x plus 6. We have to have the plus or minus because that's going to make this like the top, and it's going to make it like the bottom. Okay, otherwise if we just had this, then it would only be that top section, so we need plus or minus. So we're going to have to deal with that. Okay, so let's start writing our integral. Well, this top piece right here, this is y is equal to the positive square root of 2x plus 6. And this bottom one is going to be y is equal to negative square root of 2x plus 6. So as I work my way across, we'll do the top minus the bottom. That's going to be this one here minus this one until it gets to right here, which happens at x equals -1. So area is going to be the integral from -3 to -1 of, and we're going to integrate the top square root of 2x plus 6 minus the bottom, which is going to be negative square root 2x plus 6. Put that stuff in parentheses, dx. Okay, at that point I need to switch gears because now we have to deal with this function. So we would still have this, so we're going to say plus integral, and we're going to start at -1, and we're going to do the square root of 2x plus 6, which is this top function, minus this lower function, which is what? X minus 1. Dx, and we'll do all that stuff, and we're going to end up with 18. I'm not going to go through that process. Okay, or we can do it with respect to y. So what that means is we're going to look at the function more as a right to left kind of thing, and we're moving our integral up in this direction. So to integrate this with respect to y, here's what my integral is going to look like. First of all, I would have to solve this for x, and I'm going to rewrite that function as, let's see, add 1. X is equal to y plus 1. All right, so what is my area going to look like, or my integral going to look like for that one? Well, I'm going to go the right minus the left. So that's just this function minus this function, which is going to be y, the integral of y plus 1 minus this right here, 1/2 y squared minus 3. And this again is with respect to y. And since it's with respect to y, we're moving in this direction as we integrate, which means we're going to go from -2 to, my upper bound here is going to be 4. So we're going to use our y's to move through these. Excuse me. Either way, you're going to get 18 for these. Okay, so what do I want you to take away from this? First of all, just conceptually, if I'm integrating with respect to y, I'm moving up in this direction. Okay, and it's a different approach. Normally with respect to x, we're moving over in this direction. Do you always have to integrate with respect to y? No, sometimes there's advantages, sometimes there is not. But if you are going to integrate with respect to y, we must always write our functions in this manner where it's an f of y equals x style function, because when we integrate with respect to y, we need to have x written as a function of y. Okay, and then our upper and lower limits are just going to go from bottom to top, whereas before, again, with x, we go from left to right. All right, that's all I have for integration with respect to y. Good luck on those problems tonight. Let me know if you have any questions, friends.